let's take this example for implicit function and differentiate it. Now as you can see the diagram here, this is a diagram of a circle, and you know the general equation of a circle is x squared plus y squared equals to 1, which also qualifies as an implicit function. Now here, if you are asked to find the gradient of this, like let's take this point here, and if you are asked to find the gradient or the slope of this point here, how would you find? Now you already know that gradient means slope, and to find the gradient you just have to differentiate the function. So now, because the diagram here, which is a circle, is given by the function x squared plus y squared equals to 1, so here we do not have to, instead of making y subject and trying to differentiate it, like if you do in a different way, it would be y squared equals to 1 minus x squared, then square root on both sides will give you 1 minus x squared, so which means this will be positive and negative 1 minus x squared, so this will give you the upper curve and the lower curve here. So instead of going with this method where you are changing it into an explicit function, why not keep the same as implicit function and differentiate, right? So how would I differentiate this? So to go on with this question, finding the gradient, I need to differentiate it. So what I would do is differentiate x squared with respect to x plus differentiate y squared with respect to x, which is and also differentiate 1 with respect to x. Then I'm going to have, since the variables are same in numerator and denominator, directly apply the general formula. Exponents come in front, from the exponent 1 is being subtracted, then plus. Now in this case, if you remember the part 1 explanation where I taught you how to use chain rule, it would be easier in this example too. Otherwise, for the easy remember sake, just remember that if you are differentiating a variable with respect to another variable, you can consider firstly as if you are differentiating with respect to y only. So keep in mind, try to differentiate y squared with respect to y. So if it was this case here, like this case here, what I would do is bring the exponent in front, and from the exponent 1 would get cancelled, right? Now you should not forget that in actual this is not the case, right? You are differentiating with a different variable. So when you are differentiating with a different variable, the difference is you just need to mention dy over dx, the different variable. So you just have an additional mentioning, that is dy over dx. Now differentiation of constant is 0. 2x raised to 1 plus you have 2y dy over dx equals to 0. Now try to isolate dy over dx. So for that matter, you need to do some arrangement. So dy over dx is equal to negative 2x over 2y. So 2 gets cancelled. So finally dy over dx is equal to negative x over y. So this is the gradient or the slope or the tangent made by that, okay, tangent made in this diagram. Now if you are asked, let's say I'm taking this point here, and if this point is x comma, you have this y here, right? So the value of x from this point and the value of y from this point, and if you're asked to find gradient at this particular point, you don't have to worry, you just have to take the value of x and replace here. So whatever the value of x you are asked to find, you replace here, and whatever the value of y you're asked to find, you replace here, and that particular value will be your gradient. Okay, I hope you understood. Try this question to check your understanding, and the answers you can find it in the other video, part 3.